All right, section 5.6. So this is another method of integration. This is called the method of substitution. So this is what you had done your WSQ on. All of you got the WSQ correct. U had to be x to the fourth. I think it was plus 2. So we're going to do that today, trying to figure out how to integrate something that looks really difficult by substitution. And I'm going to teach you another way later, which my high school teacher taught us, which is just guess. You don't really have to do substitution. However, when it gets really, really complicated, you do want to use substitution because it helps you a little bit. And also the AP test assumes that you know substitution, so you can't just always guess. Because they will test to see if you do know how to substitute, even if you do know how to do it another way. Anyways, all right, so let's look at this example. Okay, we want to integrate this one. Put the iPad away. All right, Jonathan, put the iPad away as well. Okay, so we are going to try to integrate this one. Now, what you want to do is kind of pick the most complicated part of this problem. So something that has a higher degree than something else. So you can see that there are two parts, right? There's this 2x and there's the square root 1 plus x squared. So what you want to do is go with the one that has a higher degree. The higher degree is actually not as apparent. The higher degree is not the square root of 1 plus x squared. It is this part inside. So that part is the most complicated part, or the part that has a higher degree. So the first step is you want to choose a u. And usually that is the most complicated part. So we're going to say that u is equal to 1 plus x squared. So set u as something that is a little bit more complicated than something else. And we're going to use u and substitute into the whole thing. Okay, so the next thing, step 2, is you want to find dx. So what you do is you take derivative of both sides. So the derivative of u is just du. The derivative of 1 plus x squared is 2x. So we're taking derivative of each part on its own with respect to itself. So 2x dx. Don't forget that dx. Okay, so again, you take the derivative of the left-hand side with respect to itself and the derivative of the right-hand side with respect to itself. Okay, third, we want to substitute so that there is only u in the integral. Okay, so this part is a little bit tricky. So you can see that this 1 plus x squared is just this one because that's how we made it. So this part is going to be u. Then what you do is you look at this part, the du part. Du is 2x dx. 2x dx also shows up. So we can say that whole 2x dx is du. Okay, so now when we substitute, this becomes square root of u du. Okay, inside the square root is the 1 plus x squared, which is u. You substitute into that part, but that square root stays, okay? Square root, that was not part of the u, so you have to keep that there. Okay, now integrate with u. So this is now easy to integrate, right? So go ahead and do that. Figure out what the integral is with u. Please don't forget plus c.
Where's the 2x goes
2x, so you can see that 2x dx is du. So I just replaced it with du. So 2x dx becomes du. No, yes. The first few times you see it, it's just very confusing, especially that du part. Once you get used to it, you kind of know what you're looking for. Okay, so just integrate right now. Integrate square root u. What is square root u? Make sure you have a plus c. that is u to the 1/2, right? So 1 power higher would be 3/2. All right, so the answer is 2/3 u to the 3/2. Please don't forget plus c. However, we don't want this answer in u. We want this answer in x. So what should we do now?
Plug in 1 plus x squared.
Yeah, plug in 1 plus x squared. So please don't forget that, when you do substitution, you do have to substitute back. Okay, so 2/3, 1 plus x squared to the 3/2 plus c. Okay, so this is the answer. All right, so I'm going to show you the steps of how to do this. You can't copy it down. You don't need to copy it down because you can do it so many times that you'll just remember it. Okay, first step. You want to choose a u, usually the more complicated part of the integral. I say usually because sometimes it's not very apparent. Step 2, find dx. So you want to integrate derivative of both sides. Step 3, substitute so that there is only u in the integral. Step 4, integrate with u. And step 5, substitute back. All right, so let's look at another problem. Sorry for those of you who are copying down. Okay. If you're copying down, let me know when you're done. Okay, so the steps become more apparent the more you practice. All right, let's look at the next one. This one. Integral of x squared e to the x cubed dx. Okay, again, we want to choose a u. What's a u you want to choose? Or what's the most apparent u? X cubed, very good. Okay, u is x cubed. Step 2, we want to take derivative of both sides. So on the left, what do you get? Du, very good. And then on the right, you get 3x squared, and don't forget the dx. Because we need the dx to be able to substitute it back. Okay, now let's take a look at this equation. We have x cubed, which is what we want, which is this u. We want this x squared dx, which is x squared dx, but I don't want that 3, right? I don't want that 3 there. So what I want to do is now do a little trick here. I am going to divide both sides by 3. I'm trying to force it so that the whole thing substitutes back, and it will replace exactly. Okay, so now you can see that this x cubed will become this x cubed here. This x squared dx is this x squared dx here. Right? So the whole thing substitutes in. Okay. U is the x cubed, so this is e to the u. X squared dx is 1/3 du. So 1/3 du. So this is the most confusing part, that you need to make sure that it fits exactly. So if there's a coefficient, you got to move it on the other side so that the whole thing substitutes in on the other side, like that. Okay, so now integrate. Make sure you have a plus c. All right, so this answer becomes 1/3 e to the u plus c, right? The integral of e to the u is just e to the u. And then last thing we want to do is just substitute back. So this is e to the x cubed plus c. Yeah?
Why would you multiply by the exponent of e, like the derivative of x cubed?
Say it again.
Like, why wouldn't you have to multiply the final answer by like 3x squared, since x cubed is the exponent of e?
Sorry, one more time.
Like, for this, why wouldn't you have to find the derivative of u and then multiply it here since it's x cubed.
You mean like if I wanted to double check?
Like, wouldn't you have to multiply by the derivative of u because it's...
Yeah, derivative of u is just 1. Because the variable right now is u.
Oh, so you...
We're ignoring... So when we substitute in, we're just going to only focus on u. X is gone. Once we figure out what it is with u, then put x back in. Yeah. Okay, let's try another one. It's going to get a little bit trickier. Okay. Now we have trick stuff, but it's kind of the same. All right, let's work on this together again. What is u? Mm-hmm. Oh, I think this is the same question I gave you on the WSQ, huh? All right, so then we want to take derivative of both sides. I'm sorry, no +2 there. All right, I need to substitute directly back. In my original equation, there is a cosine x to the 4th plus 2. That is going to be a u. I only have an x cubed dx, but in my du, I have a 4x cubed dx. So what should I do with that 4? Multiply by 1/4. So 1/4 du is equal to x cubed dx. All right, go ahead and finish the problem. Let me know when you're done. All right, this is going to be 1/4 cosine u du. Okay, so the integral of that is 1/4 sine u plus c, which is 1/4 sine x to the 4th plus 2 plus c. All right. Next. Okay, try this one on your own. This one's too easy because you don't need du dx for this one. This one. Can we go back? U is 1 minus 4x squared. Du is negative 8x dx. So that is negative 1/8 du equals x dx. Okay, when we substitute in, this part is u. This part is negative 1/8 dx. So some of you, if you made a mistake, most likely you just forgot to put this in there. Okay, you just put a u somewhere instead of 1 over square root u. Okay, and then times 1/8 dx. All right, this is just 1/8 u to the negative 1/2 dx. I'm sorry, why am I writing dx? Du. Oh. Okay, so the answer is negative 1/4 u to the 1/2 plus c. So substitute back negative 1/4, 1 minus 4x squared to the 1/2 plus c. Yeah.
So you don't put in like the negative 1/8?
I do. Oh, I forgot the negative. Sorry.
So positive?
No, because when you take the derivative of this one, it's positive, so that is still a negative. Okay, I'll help you in a second. Okay, let's try another one. Oh, this one's very easy. This one, actually, you don't even have to use u sub. You could just do it by looking at it and say, e to the cosine t is a very complicated part. I'm just going to guess. But you can use u sub because we've been practicing that. Might be a little easier. Anyways, go ahead and work on that. Okay, I'm going to give you just the answer. Negative e to the cosine t plus c. Good?
How do we get the negative?
Derivative of cosine is negative sign. Okay, next one. This one has no numbers, but you can do this one. Sorry about that. Just 1 dx is enough. the answer is 1 over a natural log a plus, ax plus b. You didn't even know there was a natural log coming, huh?